Hey, this is OXDF, and welcome to the 2025 Cyber Apocalypse CTF workshops. Today, I'm going to be working through a forensics challenge from the 2024 Cyber Apocalypse CTF, Fake Boost. And one of the things that's really cool about Hack the Box is they take last year's CTF and they put all of the challenges on the Hack the Box websites where they can be played. So let's go check that out. I'm actually going to start by going here to the track section on Hack the Box, and we can click in the little filter here, and if I type, there's a ton of stuff here, but if I click, if I start by typing cyber, I can get cyber, I get the, 22, 23, and 24 CTFs are there for playing. I'll click on last year's, and we're going to be doing the forensics challenge fake boost right here. So let's check out the description. Basically, in the shadow of the fray, a new test called Fake Boost whispers promise of free Discord Nitro perks. It's a trap, and in a world where nothing comes without a cost. As factions clash and alliances shift, the truth behind Fake Boost could be the key to survival or downfall. Will your faction see the truth through the deception? This is a cunning trial, blah, blah, blah. Okay, this is a well-reviewed challenge. So I've already got the files downloaded, so I'll take those down, and let's go ahead and jump over to my VM. The download file really is just a single PCAP file, a PCAP NG or next generation, but it's a PCAP. So anytime I get a PCAP, I'm going to go ahead and open it in Wireshark here. So let's run that in the background. And I wonder if I can make this bigger. Yeah, there we go. There's one thing I've learned recording videos: the font is always too small. All right, so right away, the first thing I'm going to look at when I open up a PCAP, the very bottom right here, packets. It might be very small on the screen, but 20,405 displayed, 20,405. Okay, so a lot of packets. There's probably, almost certainly not all of this is necessary for me. I'm noticing just kind of a quick scan through. I notice a ton of Quick. Quick is like a HTTPS. It's a secure HTTP implementation, typically over UDP. I see some TLS data. But scanning through this is not super useful. So the next place I want to go whenever I get, especially for a large PCAP, if this was like 50 packets, maybe 1 or 2 TCP streams, I would just go straight to that. But let's start with the protocol hierarchy. And this right here will show us, I can't make this bigger, so you maybe just have to squint a little bit, but or maybe I'll zoom in when I edit this. Right now we're seeing, so everything's a frame, everything's Ethernet, that makes sense. There's a little bit of IPv6, almost all IPv4. The IPv6 that is there is some stuff that doesn't look super interesting. There's some UDP with some Quick going on for sure. 73% of the UDP is Quick. I bet there's some DNS as well for sure. Nothing super interesting going on in there. We have some TCP. Under that, we have TLS, 6.7%, 1,300 packets. TLS. Quick here, 14,000, almost 15,000 packets. So we're making up most of our packets there. And then there's a little bit of HTTP. That'll be interesting for sure. A little like five IGMP packets, gonna ignore that. Some ARP, not super interesting. So right away I have an idea of the types of stuff I'm looking at. Without any kind of keys or decryption material, it's almost certain that I'm not gonna be able to look at the Quick. I'm not gonna be able to look at the TLS. Those are just encrypted. They're secure. If someone figures out a break for TLS or Quick, we're gonna hear about it. That's a big deal. So I can almost certainly assume that's not it. I'm very interested in the hypertext, the HTTP stuff. So right away, I've got an idea of where I want to go. I also, in general, like to look at the endpoints and or conversations. We'll start with endpoints just to start here. And what this gives me is similarly, I got a summary of what's going on in the packet. So everything's Ethernet. This is not super interesting, but under IPv4, now I've got all the hosts that are involved in what's going on here. And I can sort by number of packets and see what are the main players here. I can see of my 20,000 packets, 20,405, 20,200 of them involve 192, 168, 116, 138. That's probably the host we're collecting from. I'm just going to throw that out there. Or at least if we're collecting from some midpoint, it's the main host that we're looking at. In a real large network, we're going to see certainly more, but for this, like in CTF, it's always good to identify the main host. There's a lot of stuff going to 5.22. Now that lines up pretty nicely with the amount of Quick I was seeing earlier, so that's maybe that's the Quick. TCP wise, I can look at ports, same thing. Port 80 is certainly interesting, and 8080 could be interesting. And then like I said earlier, I'm not super interested in all these 443s. And then these rest of these are just random high ports, could be interesting, but also could just be, when the client, if you look at all these ones coming from 116, 138 with a high port, that's probably a high port talking to, 443 or 80, one of these other ones. So they're probably not super interesting. The UDP, there's a lot of 443. That's the quick activity, and again, some client stuff. Cool. That's our summary. Based on all of that, there's a ton of this HTTP. There's like I said, a ton of encrypted stuff that I'm not super interested in. So if I come in here and I could do something like put a filter in here, say TCP.port is not equal to 443 and hit enter, right away, look down at the bottom here, 20,405 packets, displayed 37. Now, this is only showing me TCP packets that are not 443. So by definition, probably interesting. I want to look at those 37 packets. But just in case, if I want to be a little bit more complete, I could also say or not TCP, and now I'm right back up to almost 16,000 because that I brought in all the UDP stuff. So I could start to mess with this some more and say and not quick maybe. I'm down to 1,068 packets. I could also say and UDP port is not equal to 443. I'm down to 193 packets. So there's ways I can look at this to sort of filter out what's left. There's still some DNS going on in here. I could do a quick scroll through the DNS. There's not anything super interesting. This is really, most of this UDP stuff doesn't look super interesting. So what I'm actually going to do, just to make my life easier, is I'm going to go back to that not TCP not 443, and I'm going to actually export this. Export specified packets. I'm going to call this TCP not 443 and save. And what I'm actually going to go back and reopen this. I don't want to forget about this packet, but I want to start looking at this because if I can solve the challenge with just this, then it's just going to make getting through this in data a lot easier. Cool. Let's see how much, what can we do next? Let's see, we're going to take a look. I'm going to go ahead and find one of these TCP strings and do follow TCP stream. And at this point, I'm just going to kind of skim through real quick. There's only 3 streams, stream 0, 1, and 2. I got my view in raw here. I want to switch it back up to ASCII. Okay, so let's go back here and take a look at our 3 streams. 3 streams, I can manage that. The first one is a GET request. So this is HTTP going to free Discord Nitro. Okay, on this 8080 port, and it's returning what looks to me like PowerShell. So you have, or some kind of, you have a variable here is equal to this long base 64 encoded string. And at the bottom of it, I've got some PowerShell looking stuff going on here. I'm definitely going to want to take a look at that. The second one is a get to connectivitycheck.ubuntu.com. Almost certainly not interesting. And the last one is a post request to, I'm not going to try to say that, with some data going on here. And it just replies, okay, from a Python workzerg, so probably Flask web server. We could take a look at this. In fact, we'll take a quick look at this here. Let's go back to my terminal. If I do echo this into base 64 minus d, almost certainly it's just going to be random junk. I'm going to put it into less just so it doesn't mess up my terminal. Yeah, that's random. Look, that's not ASCII. We could put this into the ent command, and that'll show us entropy, and it's 7.6 bits per byte. I would expect for like encrypted, that's on the low end of acceptable for what's encrypted. That means, for every 8, there's 8 bits in a byte. So 7, it's pretty darn random. I like to see more like 7.9 for something like that. But let's see, we can do something like, what if I cat bin bash, if I take like a binary into ent, it's only 6 bits per byte. So there's like structure to the binary, and that's what comes through. It's not as random. Like this is pretty close to random. So it seems encrypted. I'm not going to mess with it. I'm going to look at the other thing first. Let's go ahead and run. I'm going to run code on this directory to open VS Code. And yes, I trust me. And let's go ahead and grab that PowerShell script, or what I think is PowerShell script. I'm seeing an invoke expression down here at the bottom, so it looks like PowerShell. So we'll call this discord nitro.ps1. Put paste that in. I don't need this. I don't want to take a feedback survey, and I will update this later. Okay, so right away I can see, despite it being very long in that stream, there's only 4 lines of code here. That's one of the things I really like about looking at it in something like VS Code is like right away I can get a feel for what's going on. There's 4 lines. The first line is this long setting this variable. The next line is doing something here. I'm gonna go ahead and Alt Z, and now it's line wrapped. And you can look, I love this little picture on the side because you can see the string is in orange, and you can see the orange takes up the vast majority here. But then if I skip down to the bottom, I've got the next 3 lines. So again, I'm just getting a feel for how big this is and what's going on. So it's going to take that long, probably base 64 encoded string, and it's going to save it as a character array as this thing, and then it's going to pass it to reverse. So it's going to reverse the order, and then it's going to join it back together. And then we're going to get string convert from base 64. We're going to take that thing that's been reversed and joined back together. We're going to base 64 decode it and save it as this thing. And then we're going to set invoke expression equal to that. We're going to set a new alias with the name pwn to be evoked. So pwn is now invoke expression, and then we're going to invoke expression that. So we can tell we need this string right here. We need to reverse it and then base 64 decode it. And then we will have some more PowerShell, hopefully. So let's see, let's go back to our terminal. I'll just echo, open parentheses, paste, bam. Now, if I just go straight to base 64 minus D, it comes out as junk. So that's not right. Oh, and I even lost my terminal. But that is AC. Yeah, let's get myself a new one. So if I do echo like that, I don't know why the terminal's acting weird about this, but we're going to put it into rev and then base 64 minus D. And that looks like PowerShell. So if we do that again, we can now save this as Discord Nitro 1. I'm getting very creative here. And we'll come back to VS Code and open this up. And this one, again, just looking on the side here, I don't know if I have wrap on or not. Yeah, it looks like I have it not wrapping at the moment. But this one right here, you can see, it looks much more like code. There's not like a giant block in here. I'm going to go ahead and shrink down the functions since they look to be named with what they do. So I'm going to shrink those down. I don't need a terminal at the moment. So what do we have these functions defined. We have a URL right at the front, and that's the URL we saw on the 3rd stream. So whenever this URL gets used, we know, we have an instance of it being used. There's functions here: steal, generate Discord Nitro codes, get user info, or get Discord user info, create AES managed object. We thought that 3rd stream might have some encrypted data in it. Now we've got AES discussions going on. Encrypt string, encrypt. And then here comes the rest of the thing. So we start off with a write host. We're going to print out some cool ASCII art here. We're generating Discord Nitro keys. Please be patient. We're getting the local and roaming app data profiles on a Windows machine. We've got this thing called part 1 that looks kind of base 64-y. One of the things you have to learn when you're doing CTFs is, especially forensics challenges, people can't just put like HTB, squiggly, and a flag into the forensics data in plain text, because you would just grep the whole file for it and it would just pop right out, right? In fact, I bet you I haven't tried this, let's see. If we grep for that on, it does not come out. Okay, well, sometimes it might. Anyway, that's not, the point is, there's layers of encoding. Oh, so let's take this. If I come back here and echo base 64 minus D, we have half of a string. It doesn't end in, so it looks like free nitrogen exposed. And it was called part 1. That makes sense. So we got the first half of the flag. We set some paths, and these are looking like the profile paths for various browsers. We have some headers for some HTTP requests. We create an array called all tokens. We then loop over each path key, so each browser, and we are going to test if it's there, and if it is there, we're going to try to call the steal function on that path and add the results to all tokens. We're going to loop over each of all tokens, and we're going to call user info. So we're going to get information about the user and save it there into a PS object. We then have an AES key. That'll be certainly useful to have. We're going to take the user info, convert it to JSON, save it as a payload. We're going to pass that payload into encrypt string with the AES key. And then we are going to invoke REST method. So post it to the URL with post encrypted data to the URL. We've seen that. We've got that. So that's cool. I'm guessing we need to go there next. We could look in detail at some of these other functions, but I think we know what they do. Maybe we'll come back to that at the end if we're curious about it. And then it prints to the host success. Here's some keys, and it generates some nitros, some codes. That's another place a flag could be. We'll want to check that out. And it prints them to the screen. That's probably, let's take a look at that real quick. So we're looking for generate Discord nitro codes. Ooh, say that 5 times fast. So we take in code length, number of codes, characters. We're getting random, Control Alt Z to wrap, and we are just getting any random characters and make codes. So we're just making completely random codes. So the point of this script is, I'm a bad guy. I send this to you and I say, hey, get some free Discord Nitro codes. And then you say, cool, and you run it. And it runs for a second in the background, checking all my different browser profiles, looking for tokens of certain kinds. So Discord, presumably because you're looking for free Discord Nitro, which is like an upgrade on Discord. You probably have Discord installed on your computer. I'm going to try to find your Discord tokens and steal your identity, basically. So let's see. That's not super interesting. So let's check out the encrypted data. We can go check out encrypt data. Where is that? Encrypt string here. And that is going to get the bytes. It's going to create an AES object. It is going to, let's see, what does that look like? That long? If no mode is given, let's see. Interestingly, it doesn't look like it passed a mode in when it called it, so I'm not exactly sure what we're using there. We can sort of play with that a little bit. It's just going to encrypt everything, and then it's going to return, so this is important, full data is the IV plus the encrypted data. That's always good to know. And it's going to base64 encode it. And do I have anything else I need to know out of here? I don't really see. So it's calling create manage AES object. And it's passing just the key and not the IV in the mode. So down here, if the IV is not set, presumably it's going to generate a random one, I think. Let's see. I guess if you don't pass in an IV, it's just going to pass that generate random one. I'd have to look into the documentation of this. I'm going to make some assumptions and just go forward. So I want to take a look at this data and see if we can crack it. We might not be able to. We might have to come back and do more research, but let's see if we can crack it. There's a couple ways I can approach this. Let's see. First one, I'm going to open up a new window here. I'm going to do some Python, and we are going to need some libraries. And Python right now is, in modern Python, you're not supposed to, and they made it really hard to install libraries to the global space. So what you need to do is create a virtual environment. So we're going to run Python -m venv venv. That is to say, run the venv module, and I want the output to be a directory called venv. I could make this something else, so I can call it mvirch. Doesn't matter. As long as just by habit, I always run venv venv. I want my things to be that. You can see here it's created a directory. If we do a find on mvirch, there's all sorts of stuff in here. It's almost like it's got a Python configuration there. What we're going to do now is we're going to source bin activate. And now we've told, if we say like which Python, where's Python on my system? Oh, well, it's actually in this envert bin Python. So we're actually using what's in there now. So now we can pip install. Install, see if I can remember the name of the library. I think it's just cryptography maybe. There definitely is a cryptography. Let's see if it works. So if I now do Python, I'm in Python. If I do from crypto.cipher import AES, no module named crypto. Okay, I installed the wrong module. Pip install. Is it just crypto? YPTO. And we run that again. And all right, hold on one second. Let's see. Crypto.cipher. Let's see what this is. What is PyCryptoDome? Is that what I want? That's a good guess. Let's try pip install PyCryptoDome. I probably should uninstall those other ones. Uninstall cryptography, CRYPTO, just so I don't have a messy. Yes, we're going to do that. Oops. Okay, we are done here. Okay, so now Python. Let's try this one more time. Up arrow from yes, I've got an 18 thing. I'm also going to need to base 64 decode some stuff. So I do from base 64 import b64 decode. Now, if you are not comfortable on a command line or not comfortable in Python, hang tight because I'm going to show you how to do this in CyberChef as well. It's a little bit more, it's a kind of a complicated CyberChef recipe. We're going to do it. But real quick, I'm going to say enc full equals and grab. Let's see, where was my encoded? Oh, in the pcap. So follow the stream. Let's go back here and grab this stream right here. Copy you, come back to my terminal. I'm actually gonna call b64 decode on that. So I can do like len enc full, hit 544, enc full, fill full, random data. Okay, I got it. So now I'm going to say IV is equal to enc full, and in AES, the IV length, the block length is typically 16. So I'm going to say the first 16 bytes is the IV, and I'm going to say enc equals enc full 16 and onwards. And so now I've got the encrypted text and the IV. I know the AES key is equal to b64 decode. And where would I have that in here? Grab you and paste that in. So I've got the key. And now it's just as simple as saying, I'll say like cipher is equal to AES.new, and I pass it the AES key. I'm going to need to pass AES, and I'm going to have to pass it a mode. I'm going to just guess that it's CBC. That's usually the default. I could try different ones and see what worked out. But we're going to go with that, and I'll give it the IV. Now I can say plain text is equal to cipher.decrypt enc. So give it the text, and we'll see if that is good. We will print pt. That's going to be binary, so we'll decode it because if this worked, we think we're going to get plain text, and we did. Let's see what's in here. These tokens look kind of like auth tokens for Discord, maybe. Here's some thing. This looks to be repeated data. I don't know why the email is base 64. B64 decode. Because that's the flag. So I got the other half of the flag that way. Sweet. That was it. Let's run back real quick and we'll go check out CyberChef because this is kind of fun too. CyberChef. We want the GCHQ one. That is correct. And we're going to load it here. So what do we want to do? We want to go ahead and get the data. And this is where, okay, so the fact that the IV is connected to the data is where this is kind of a pain. Let's go back. Let's maybe go down to my terminal. Where was it here? This looks like it. So this is where we're going to use registers. And this is a cool kind of advanced CyberChef technique. You can also kind of do some on your own, like cutting this up in the terminal and rearranging it, but it's kind of fun to be able to do it. So we're going to do we're going to do base 64. So we're going to convert this to data, garbage data. Now, you don't have, the next step thing I like to do is go ahead and convert it to hex. Now you don't have to do this, but I find working with hex is so much easier when you start doing registers. Maybe if you're more advanced, you can skip this part, but now for me, this is just easier. So, okay, so now I've got this hex data. First thing I want to do is I want to pull the IV off. So I'm going to do a thing called register. If I come here and put this in, my extractor is going to be the start of the string. So if we're doing regex, the start of the string, then anything. If I just leave it like this, it's going to be one. So see how it's pulling that 6 off? Now I want the first 16 bytes, which in hex is going to be 32 characters. So I'm going to put 32, oops, we'll do squiggly brackets 32. And you can see right here, now it says R0 is equal to C, and that might be kind of small. R0 is equal to C6, 6C41, blah, blah, blah. And that's the first 32 bytes right there. You can see I have 32 selected. That's really tiny. You probably can't see, but trust me, it says that. So I've got 0 to 32, and then that's it. Now, I need to pull off, I want to pull that data. I don't want that to continue in my output. I want to just store it in that register. So the next thing I'm going to do is going to do a find and replace recipe. And as we scroll down, so what am I going to find? Well, I'm going to find the start dot 32. I'm going to take that. I'm going to replace it with nothing. And what actually, if I turn this off, you'll see, remember I had, when I selected the first 32, there's 32 to 555 here. The next thing is 1B C5A7. Boom, 1B C5A7. So I've just removed the IV from the data. So now this is all the encrypted data. So now I have everything I need to just do AES decrypt. Let's add this to the bottom. Now the key, we need the key. The key is going to come in as base 64. So let's go grab it. Where did I have you? Right here. Copy, paste in base 64. The IV is $R0. And I don't even have to, whoa, okay. Thank you for all yours. And the IV is in hex, which it was because I stored it in hex. The mode is CBC. The input is in hex. So it's taking in the hex input and the output is raw, and boom, you can see we got the same data here. So registers are super powerful. It's a way, so anytime you've got data in your pipeline that you want to pull something out to use, as an IV, for example, that's the way to do it. It's a little bit bulky because you have to both figure out how you're going to extract it and then figure out how you remove it if you want to. But you can do all sorts of cool things with this, with registers in CyberChef. So it's an advanced technique worth checking out. That's it. Thank you so much for attending this workshop with the CTF, and I really hope you enjoy it. Go out there and have some fun. If you're competitive, best of luck. I hope you compete and win. And if you're just here as a beginner or doing this for the first time, have fun with it. Don't feel pressure like you have to be on the top of the scoreboard. Find some challenges you can solve. Focus on the easier ones. Build a community, work with some other people, and have fun. That's the real point. So, thanks. This is OXDF. I'll talk to you next time. Bye.